Here I'm going to introduce the binomial distribution, or finding the probability of something called a Bernoulli trial. Now this is a question that comes up quite a lot in the papers, and a Bernoulli trial is essentially an experiment where there is only two outcomes, and what we say is that one of the outcomes is success and the other outcome is failure. The probability of success we call P. So quite often what we're asked to do is we're asked to find out what's the probability of a certain number of successes in an overall certain number of independent trials. So there's a few conditions that have to be apparent in a Bernoulli trial, and this is what I state here. So you have to have a fixed number of repeated trials. There is only two possible outcomes, success or failure. The trials are independent, that means one does not affect the other, and there is a constant probability of success. So what I'll do is I'll go through some exam style questions on Bernoulli trials now. Okay, so here's one such question. Write down two properties of a Bernoulli trial. We listed the four out previously. Two outcomes, success or failure. They have to be independent of each other, the trials do. And there's a finite number of trials, okay? So have a look back at the list there for that. So in the next question, we're told that a football player takes 10 penalties during one season. The probability that he scores is 3 in 5, so 60%. Find the probability that he scores exactly 7 of the 10 penalties, correct to 3 decimal places. So we know this is a Bernoulli trial because we know there's only a fixed number of trials. We know there's only two outcomes, success or failure. And we have a definitive probability that he scores, which is 3 in 5. So therefore the probability that he fails to score is going to be 2 in 5. Now the probability that he scores exactly 7 of the 10 penalties. The formula for working this out, probability of 7 goals, is going to be, well, it's 7 out of the total of 10 that he's taking, so that's going to be 10C7. Look back at the combinations video for that. And then it's going to be the probability of success, which is 3/5, we're told in the question, and he needs to score 7 of those, times the probability of failure, well, that must be 2/5, all to the power of n minus r, which is 3. That gives us a correct answer of 0.21499. It says to 3 decimal places, so the answer is 0.215 is the probability there of success. So as we can imagine, the probability of him scoring a penalty is only 60%, so 6 in 10. So overall, the chances that he's going to get 7 out of the 10 is fairly low, which is 0.215. So then in the next question you're asked to find the probability that he scores his 7th penalty on his 10th attempt, correct to 2 decimal places. So we're looking at two things here. If he's scoring his 7th penalty on his 10th attempt, then he must score 6 of the first 9. So that's where we're going to use our Bernoulli trial. And then if this next event has to happen, we multiply by the probability of it happening on that 10th attempt. So he has to score 6 of the first 9, which is going to be 9C6 times our probability of success times our probability of failure, and we need to multiply that by the probability that he's going to score a 10th penalty, which is 3/5. So overall that figure is equal to 0.15049, but it's to 2 decimal places, so 0.15. So quite a low chance that all of that is about to happen. So this is a Leaving Cert paper from 2017, question 1. It's paper 2. You're asked, Connor ring Kira's house. Probability that Kira answers the phone is 1 in 5. Connor rings her house once a day for 7 consecutive days. Find the probability that she will answer the phone on the 2nd, the 4th, and the 6th days, but not on the other days. For this one, to be honest with you, it's probably easiest just to multiply out each of the probabilities. So we know that if she answers, it's 1 in 5. So on the first day, she doesn't answer, and then we're told that she will answer on the second day. So that's going to be 1 in 5. She doesn't on the third, or she does on the fourth. She doesn't on the fifth. She does answer on the 6th, but not on the 7th day. So we're looking at 4/5 to the power of 4 and 1/5 to the power of 3 multiplied by each other. So the total probability there is going to be 256 out of 78,125. So you can leave them in fraction form. In decimal form, that's going to be 0.0032768. In the next one then we're asked, find the probability she answers the phone on the 4th time on the 7th day. So here we're looking at our Bernoulli trial. If it's the 4th time on the 7th day, that means for the first 6 days she only answers it 3 times. We don't really mind what order. Okay, so we definitely got our Bernoulli trial. So it's going to be 3 from 6. Probability of success there of those 3 is 1/5, so it's going to be 1/5 cubed times the probability of failure cubed, because there's 3 days it fails, times answering it then for the 4th time on the 7th day, times 1/5. So our answer there is going to be 256 over 15,625. 256 over 15,625. So in this question we're asked to find, in terms of n, the probability that Kira will answer the phone at least once. Whenever you're asked a question about someone doing something at least once, well, we have to go back to the probability of an event occurring, an event not occurring. So if she's answering the phone at least once, then we need to think, well, if she's answering at least once, when is she not answering the phone? The probability of her not answering the phone is 4/5. And if she was to not answer the phone every day for n days, it would be 4/5 by 4/5 by 4/5 all the way up to n times. So that's going to be 4/5 to the power of n. We know that is the probability that she will never answer the phone. The probability that she answers it at least once is going to be 1 minus the probability that she never answers the phone. Find the minimum value of n for which the probability that Kira will answer the phone at least once is greater than 99. Okay, so we've kind of set ourselves up with the last question. That's the probability that she will answer the phone at least once, i.e. 1 minus the time she never answers the phone. Now we're asked, find the minimum number of n for which the probability that she answers the phone at least once is greater than 99%. Okay, so we're just going to set up an inequality. That's greater than 99%. As a decimal, that's 0.99. Just to answer this in a stepwise fashion, I will subtract 1 from both sides. So we're left with minus 4/5. Power of n is greater than minus 0.01. I don't like the minus there, so I'm going to multiply everything by -1. But because that's an inequality, then I need to change the sign. So we've got 4/5. I'll just change that to be over here. 4/5 over n is less than 0.01. So now we can just take the log of both sides. So we've got log 4/5 the n less than log of 0.01. So when we get to this point in the equation, we know that n times the log of 4/5 less than log 0.01. So I'd need to divide both sides by the log of 4/5. Because we're taking the log of a fraction less than 1 there, that's a negative number. So when I'm dividing both sides by the log of 4/5, as it's a negative number, the inequality sign will change. So it's n greater than log 0.01 over log 4/5, which gives me a value of n being 20.6377. So n has to be greater than that. The minimum value of n then is 21. So there, I've looked at some probability questions involving Bernoulli trials. In the next couple of videos, all I do is practice some more past paper questions, or past paper style questions based around probability and conditional probability and things like that. Main thing from this to remember is our properties of a Bernoulli trial and how to calculate the probability of success overall. And that is summarized here again.